Hello guys, in this video today I will we will learn about the state in Jetpack Compose. So in the previous videos what we have done is completed those code lab, completed this code lab, completed implemented real world design this code lab, modifier and all, and now we will learn about this code lab, getting started with state. You learn how apt state determines what to display in the UI, how compose keeps UI updated when the state changes, how to optimize structure of a composable function and work with view model in a compose app. So we will go through this code lab. This code lab is this, okay? So it will take 1 hour, or if we go deep, it will go to 3 hours maybe. Okay, now so let's jump straight to the code lab. So state in Jetpack Compose. So this code lab explains the core concept related using state in Jetpack Compose. It shows how the app states determines what to display in the UI, how Compose updates UI when the state changes, how Compose updates UI when the state changes by working with the defined API, and how to optimize the structure of our composable function. How to optimize the structure of our composable function and using view model in a compose world. Prerequisite is knowledge of Kotlin syntax, basic understanding of compose architecture, basic understanding architecture component, view model. Okay, view model is like mediator. Okay, let's ask ChatGPT. What is view model in compose? Let's ask it. View model is a class that holds and manages UI related data in a lifecycle aware way. That's a correct one-liner. So it survives configuration changes like skin rotation and keeps your UI state safe. It's common in the Jetpack architecture component. A view model is a state holder for your UI that survive configuration changes and separate business logic from UI. Why do you need a view model in Compose? Even though Compose is a declarative, we still need state management, separation of concern, survive rotation, avoid putting business logic inside composable. Without view model, your composable will become messy, low state on rotation, mix UI logic. So that's a simple counter view model. Counter view mutable state of increment. There is also a deep concept of how view model works internally. We will go through it uh, after some days. In future maybe. Counter skin view model, calling the view model, okay, and then text button click view model dot increment. UI auto, automatically recomposes the when counter changes data survive rotation logic stays inside view model. How it works in Compose? Traditional XML view observe live data from view model. In Compose directly read state from view model. Compose automatically recomposes view model changes. Compose automatically recomposes when mutable state changes. Mutable changes from this increment function. Okay, count plus plus. Okay, so here view model should be used using fetching API data, managing complex UI state business logic, database operation, sharing data between multiple composable, and not to use view model. When not to use view model, don't use view model for small local UI state like text field, text box toggle, simple animation, real architecture, UI composable view model repository API database, clean testable, scalable. In one line, interview style answer. View model. View model is a compose. View model in a compose a lifecycle aware stakeholder that manages UI data and business logic separately from composable and survive configuration changes. Okay. In Codelab, so this Codelab explain the core concept using the this Codelab explain the core concept related to state in Jetpack Compose. It shows how the app state determines what is displayed in the UI, how Compose updates the UI when state changes by working with defined API, how to optimize the structure of a composable function and using B model in a Compose work. Knowledge of Kotlin's syntax, basic understanding of Compose. You can start with Jetpack Compose to basic understanding architecture component B model. So what we will learn in this Codelab is how to think about state and event in Jetpack Compose. So how Compose uses state to determine what element to display. How Compose state determines what element to display on the screen. What state hosting is. State hosting is, removing the state and giving it to parent. We'll go through it. How stateful and stateless composable function work. How compose automatic. So how stateful and stateless composable work. So I have written a article. I'll show you. I've written an article on Jetpack Compose, which so in this article you can see that what is stateless, stateful, composition, decomposition, and state hosting means. I written this article 2 years ago. So what is state in Jetpack Compose, event in Compose, understanding stateful, stateless, state hosting, etc. So you can just go through this article. How Compose automatically tracks state with the state API. How memory and internal state works in a composable function using the member. How memory and internal state works in a composable function using the remember seriable API. How to work with list and state using mutable state of and two mutable state list API. How to work with list and state mutable state list of two mutable state list. How to work with list and state. Lists and state. How to use B model in Compose. Now, read thinking in recommend in Compose for the Jetpack basic Codelab which you have done already. So in this video, what you will build is you will implement the simple wellness application. So this app has two main functionality: a water counter to track your water intake, a water counter a water counter to track your water intake, a list of wellness tasks to do throughout the day. So a list of wellness tasks to do throughout the day. A water counter to track your water intake. A water counter to take your water intake. Okay. For more support as you working through school, check out this following code alone. Let's see what this code alone has to say.
Hi there, I'm Alejandra, Android Developer Relations Engineer.
Hi everyone, I'm Manuel Vivo, same team, same title. Welcome to this workshop where we're going to go through state in Jetpack Compose Codelab. This Codelab is a new one. We just revamped the previous version to offer a more comprehensive user experience. It covers all the concepts you need to learn about how to work with state in Compose. Why, you might be wondering? Well, state is really important for any app, as that is what gets displayed on the screen and brings value to the users.
I'm going to be sharing my screen with the Codelab text, Android Studio, and the emulator, so you can easily follow along as we solve it. We do advise that you try to solve it yourself as we go along, or at a later stage.
Yeah, you can find the Codelab by either searching for state in Jetpack Compose or following the shortcut shown on the screen. Okay, so this is the Codelab we are going to work through today. We will cover how to think about state and events in Compose, the mechanism Compose uses to track state changes and update the UI accordingly with APIs such as mutable state of, and finally, how you can use your view models in a Compose app.
So, we're going to be building a wellness app. This app will have two sections. In the top section, we're going to have a water counter, so you can keep track of the amount of glasses of water that you take throughout the day. And below, we're going to create a list of wellness tasks, like take a 15-minute walk or reach your favorite each task to mark them as complete. And save them as a separate field so you can run out the list. Now we're ready to begin writing our app, so let's start from the top. What do we mean when we say state?
State in an app is any value that can change over time. This very broad definition includes everything from room database to a variable in a class. State determines what is shown in the UI at any particular time. For example, the most recent messages received in the chat app or the scroll position in a list of items. In the wellness app, state is the number of glasses of water the person drinks, the list of tasks, and whether or not they've been completed. Let's see how Compose uses state to display information on the screen.
Awesome. So let's go to Android Studio now. And I've created a project in Compose from the Android Studio templates. And you get 5 tips to do this in the step 2 of the code. So let's jump.
So they are explaining the code alone session in a very in-depth way. You can just walk through it, or you can follow along with me. So let's get started. You have to start a new Compose project in the studio. For if you are in Welcome and the studio, click Start a new activity project. If you already have done the studio project, file new project manually. For this project, choose empty project from the available template. Or click next to configure the basic code lab. Click next to configure basic code lab. Make sure it's let mini sticker version AP level 21, which is a mini AP level Compose support. So AP levels are 20. So many AP levels support the Compose AP level 21. Okay, for more information about setting in Compose, which is an empty activity. So when you choose an empty Compose template, and the studio sets up the following for you: main activity, and then manifest, a project level builder Gradle, app level builder Gradle, file contains option, and dependencies needed for Compose. So solution for this code lab, you can get a solution code lab, say a basic state code lab from GitHub. Alternatively, you can download the repository as a zip file. You can download the repository as a zip file. You can download the repository as a zip file. You will find the solution code in the basic state code labs. So you will find the solution basically. You will find the solution code in the basic state code lab. We recommend that you follow the code lab step by step at your own pace and check the solution if needed help. During this code lab, you are presented with snippet of code that you need to add to your project. The project name is basic state code lab. So what is state in Compose? So the app state is any value that changes over time. So whatever in your screen that changes over time is state. So for example, let's uh, check out, let's see this image. Let's see the application that we'll be building. So in this Compose application, the state is uh, how many classes left. So this, if we give add one, this text will be changes above this button. So that's the state changes, and the list of list that will be added is also a state, and if if the person completed, checked or unchecked a task, it is also a state. So in this application currently I'm seeing we have three state. As a text which will be changed, the list that will be changed, added or deleted, and there's a checked and unchecked. So three state we need to handle in this application. So we'll be building this application. So let's go to state. So the app state is any value that changes over time. So this is very broad definition, and it encompasses everything from a room database to a variable in class. All the Android app display the state to the user. A few examples of the state in Android apps are the most recent message you received in chat app, the user profile picture, the scroll position of a list item. So these are all state. These are just example of state. So key idea: state defines what is shown in the UI at any particular time. State determines what is shown in the UI at any particular time. So let's start with the writing a wellness app for simplicity. During Codelab, you can you can add all Kotlin file in the root code Codelab package app module in production app. However, the file should be logically structured in a sub package. You will hard code all the string inline snippet. You will hard code You will hardcode all string inline snippet in real app. They should be added as a string resources in the string XML file and referenced using compose string resource API. The first piece of functionality you need to build is water counter. The first piece of functionality you need to build is a water counter to count the number of glasses of water you consume during the day. So the you will hardcode all the string inline snippet in the lab. They should be added as a string resources in the string XML file. And the first using compose string resource API. The first piece of functionality you need to build is water counter to count the number of glasses of water you consume during the day. Create a composable function called water counter that contains text composable that displays the number of glasses. The number of glasses should be stored in the value called count, which can hardcode for now. Create a new file water counter with a water counter composable function like this. Water counter modifier value count. You have head count classes padding modifier dot padding 16 dp. Now it's good practice to provide a default modifier. Now it's a good practice to provide a default modifier to all composable function as it increases reusability. It should appear as the first option parameter of the parameter list after all required parameter. Let's create a composable function that represents the whole screen, which will have two sections, the water counter and the list of wellness tasks. For now, we will add our counter. Create a file wellness screen which represents the main screen and call our water counter function. Create a wellness screen which represents the main screen and call our water counter function import. That wellness screen modifier water counter. Open the main activity and remove the greeting and default preview composable. Call the newly created wellness screen composable inside the activity set content block. Set content basic state Codelab theme, a surface container which using the background color from the theme. So open the main activity and remove the greeting from the default preview composable. Call the newly created wellness screen composable inside the activity set content block. The app theme uses main activity inside set Codelab depend on how the app is named. The app theme used in main Codelab inside set Codelab depend on how your project is named. So this Codelab assumes the project is called basic state Codelab. If you copy paste code from the Codelab, don't forget to update basic Codelab in the name of the theme available in the UI file. Now the state of water counter composable function. Now the state of the water counter composable function in the variable count but have a static state is not useful and cannot be modified. To remedy this, you will add a button to increase the counter to track the amount of glasses of water you have throughout the day. Any action that causes the modification of the state is called event. Any action that causes the modification of the state. So there is an important concept here. If you click on the button, that's called event. Okay. Any action that causes modification of the state. Any action currently in this case this is a button click. Any action that causes modification of the state. State means 0. This is the state. So bell count. This is the state. Okay. Any modification, any action that causes the modification of the state is called event, and we'll learn about this in the next section. Okay, so let's open up the Android Studio, create a new project now. Let's start with this mini. Let's give it a Minium API level 22. So here we have created a new Jetpack Compose project. Let's give it a go. Put the initial code. Let's copy this water counter composable and let's leave this here. Preview. Water counter staking modifier. That's default because Kotlin recommended to modify it from outside. It's a good practice. So water counter is count 0. Text, you have had uh, count glasses. Did they give scaffold or what? Create a wellness skin which can represent main skin called water counter. Wellness screen. Water counter modify. Open the main activity. Remove the greeting. Remove the greeting and default preview composable. Call the newly created wellness composable inside the activity set content. Without scaffold, I need to give it a surface. Let's import the surface from material 3. Material theme, material 3. Okay, let's remove this edge to edge. Okay, now let's run this application. Let's try to run this application after downgrading the minimum SDK to 23. Let's run this application. Let's see what it takes as. So recommended action: update the project to newer compile SDK to at least 36. Let's just sync it here. So the build is successful. Let's run this application now. So currently the app just launched in my physical device. Let's show you what it's currently look like. See, Now the application is showing you have 0 glasses. Okay, so let's go from there. Okay, so this is a state. Okay, we have not given its mutable state, but we will give it. And there's a text. We have had 0 count classes. So the state of the water count composite function is a variable count, but having a static state is not very useful and cannot be modified. To remedy this, you will add a button to increase the count and stack the amount of classes of water you have throughout the day. So any action that causes a modification of the state is called event. Any action that causes a modification of the state is called event, and we will learn more about this in the next section. So let's learn about the event. Okay. So we talked about the state as a we talked about the state. We talked about state as any value that changes over time. For example, the last message you received in last message you received in a chat app. Last message you received in a chat application. But what causes the state to update? In Android app, state is updated in response to event. State is updated in response to event. Okay. So events are input generated from outside or inside the application, such as the user interact with the UI, for example, pressing a button. Other factors such as sensor sending a new value or network response is also an event. Okay. While the state of the app offers a description what to display in the UI events, while the state of the app offers a description of what to display in the UI events are the mechanism through which the state changes, resulting the resulting in changes in the UI. So state and event, two of the example we've just learned. Okay, key idea: state is events happen and state is. Okay, so event notify a part of program that something has happened. In all Android app there is a core UI update loop that goes like this: event, update state, display state, UI update loop. Okay, you click a button, something has updated and updated state, and this updated will be displayed in the UI. Okay, that's a loop of UI updated loop. Okay, now event is an event an event is generated by the user of another part of the an event is generated by the user or another part of the program. Update state: an event handler changes the state that is used by the UI. An event handler changes the state that is used by the UI. An event handler changes the state that is used by the UI. Display state: the UI updated to display the new state. The UI is updated to display the new state. Display state: the UI is updated to display the new state. An event handler changes the state that is used by the UI. Managing state in Compose is all about understanding how state and event interact with each other. Managing state in a Compose is all about understanding how state and event interact with each other. Managing state in Compose is all about understanding how state and event interact with each other. Managing state in Compose is all about managing state in Compose is all about understanding how state and event in Compose Managing state in Compose is all about understanding how state and event interact with each other. Managing state in Compose is all about understanding how state and event. Okay. Now understood the three core concept: event, state, update state, display state, event and state. Okay. Now add the buttons so the user can modify the state by adding more classes. You can go to the counter compose function at the button. Particularly. So let's add a button. Let's add a button below, let's say button below, and wrap this button into a column so that it is showing here that we will fix it because what's the well cannot be reassigned. Okay, let's give it a bar then. Wrap this in wrap this in column, wrap this in column, but okay, there's the on click is the event. Okay, let's see that how the application currently look like. So the on click event passes onto the button uses in Kotlin lambda syntax. To learn more about lambdas in Kotlin, check out this code lab. We don't need to learn. Okay, when your app runs when your app when you run the app and click on the button, notice that nothing happens. Setting a defined value for count variable does not make compose detect. So setting a defined values for the count variable won't make compose detect it in a state changes as nothing happened. So this is because you have not told compose that it should redraw the screen, that is recompose and composable function which state changes. So currently that's if I run my application, that's the kind of screen. And if you click on the add one button, which should increase the classes to 1 2 3 4, like they should increase the count variable, but while pressing on this event you should increase the count variable, but it's not doing it because so here you can see in code, in after on click it should increase, right? It should increase, but it is not increasing because we have not told compose that it should redraw skin. There is a concept called recomposition, so that's why it is not reflecting the changes. You might be tempted to add log in logcat debug compose function, try to configure it out if they work properly. However, be aware that this process might not be reliable when working with the compose due to, for example, decomposition being discarded. Let's do an example. Let's add a logcat and see if it's updated there. Just wait. Let's run the application, and when clicking on the button, let's see what log we get. So how you can see, on image count is 0, and if we press, nothing happens. Nothing happens. It's not updating. But what here it says to add logs and logcat to debug a composer function to try to figure out if they work properly. Be aware that this process might not be very reliable when working with composer 2. For example, the composition being discarded. Okay, it's not working. Also in Jetpack Compose, let's put this log inside the button and then run this application. Let's see. Yeah. So in on click the count is increasing, but in on click method the count is increasing to 1 2 3 4 5 6, but it's not reflecting in the UI because when it goes when this function calls, for example, it's when you click on the button it gets 1, right? And when we call this compose button from this wellness screen, it doesn't survives the I mean recomposition. So that's why it gets to its initial variable, which is 0. So let's remove these logs. So compose apps transform data into UI by calling composable function. Compose app, compose app transforms data into UI by calling composable function. We refer to the composable as the description of the UI. By compose, when it's executed, composable. If a state changes happen, compose executes the affected composable. When we refer to the composable, composers have transformed data into UI by calling composable function. We refer to the composition as the description of the UI built by compose when it executes composable. If a state changes happen, compose re-executes the affected. If a state changes happen, compose re-executes the affected composable function. We refer to the composition as the description of the UI built by compose when it executes composable. If the state changes happen, compose re-executes the affected composable function with the new state, creating an updated UI. This is called recomposition. We refer to the composition as the description of the UI built by compose when it executes composable. If the state changes happen, compose re-executes the affected composable function with the new state, creating a new updated UI. So compose apps are transform data into UI by calling composable function. We refer to the composition as the description of the UI built by compose when it executes composable. If a state changes happen, compose re-executes the affected composable. If a state changes happen, the compose re-executes the affected composable function and with the new state, creating an updated UI. This is called recomposition. Compose also looks at what data an individual composable needs, so that it only recomposes a component whose data has changed and skips those that are not affected. Okay, hope you understand this point till so far. The composition means a description of the UI built by a compose when it executes composable. Composition is a description of UI built by a compose when it executes composable. Initially creating the composable by running composable the first time, recomposition, rerunning composable when updating the composition when data changes. To be able to do, compose needs to know what state to track, and so when it receives an update, it can schedule the recomposition. Compose has a special state tracking system in place that schedule recomposition for any composable at this particular state. This lets compose be granular and just recomposes those composable functions that need to change. Not the whole UI. This is done by taking not only right. This is done by taking not only writes that is state changes, but also reads to state. So use compose state and mutable state type to make the state observable by compose. So use compose state and mutable state types to make state observable by compose. compose keeps track of each composable that is the state value. So compose keeps track of each composable that rates the state value proposition. The state value properties and trigger the composition when its value changes. You can use mutable state of function to create observable mutable state. So compose keeps track of each composable that is the state value value properties and trigger the composition when its value changes. You can use the mutable state of function to create an observable mutable state. It receives an initial value as a parameter. So compose keeps track of each composable that is the state in the value. So use a compose state and mutable state types to make state observable by compose. Okay. Compose is a special state taking system. So you'll use this state taking using this mutable state. Okay. Compose keeps track of each composable that is state value properties trigger the composition when it changes. You can use a mutable state function to create observable mutable state. Mutable means it's changeable, as the name says. It receives initial value and the parameter and is wrapped in the state object, which is then makes it value observable. So composition also has a other compose also other variable mutable state to such as mutable in state or mutable long state or mutable first state or mutable double state which optimized for primitive type. For those simplicity code level keep using the generic variant which is mutable state. Update the water count compose for the count uses mutable state API with 0 as the initial value as mutable state it has mutable type. So we will do so this doesn't work because of recomposition. So we have to wrap this in a mutable state and a mutable state observable. Okay, this showing error. Creating a state update in the composition without remember. Okay, we're not using remember. So we'll REM. That's wrap inside remember. Okay. So you might be getting certain composition without using remember. This is a valid warning will be explained fixed shortly. You can ignore this for now. As mentioned earlier, any change that counts to give count dot value. Okay, if you want to remove this count dot value, we can simply give a delegate which is by. Okay, it will import the getter and setter under the hood. Wait a second, I'll show you. And we have to import it manually. It's not giving this alt option to import it. I'll talk about this later. So just to remember that if we give the by, we don't need to give the value parameter. Okay. So as mentioned here, any changes in the count schedule, decomposition and composition. So if you run this application, notice again nothing happens yet. Scheduling incomposition is working fine. However, when a decomposition happens, the variable count is reinitialized back to 0. So we want to preserve the state across composition. For this, we can use the remember composition inline function. Embedded calculator remember is stored in the composition during embedded. So we need to wrap this value using remember. So what this remember does is using remember as a mechanism to store single object in a composable in the same way that private variable property does in object. Single object in composition using remember and mutable state as together in a composable. So usually remember and mutable state are used together in composable function. For this is for observable this is observable to observing the changes and remember is to preserve the state during recomposition. Okay. Remember the previous value. So these both are used together. So there is a few equivalent way to write this question in the C compo documentation. So that's it. Alternatively, we could simplify using the value in the Kotlin delegated property. So that's the delegated property. If we give what I was talking about. If we add this to import and if we delegate, use the delegate by remember, bar count by remember. So with the bar count by remember, we only have to give the dot value parameter. Okay. So we should pick the syntax and product register in the composer. Let's examine what will the answer for define variable that to remember over time that call count created a text to display where where we tell the user the number we remembered, adding button that increment the number we remembered, adding a button that increment the number we remembered whatever it's clicked. So this arrangement forms a data flow feedback loop with the user. The UI present the state of the user. The UI present in the state of the user. The current count is displayed as stack. The user produces event that are combined. The user produces event that are combined with existing state to produce new state. Clicking button to add, adds one to the current count. Your counter is ready. Your counter is ready and working. You might already be using other observable type like live data, flow, and Rx Java is observable to store state in app to allow compose to use this state and automatically recompose it. So when the state changes, you need to. So you might already be using other observable types like live data and state flow. So you might be already be using other observable types like live data, state flow, and Rx Java observable to store the state in the app to allow compose to use this state, and automatically recomposes when the state changes. You need to map them to a state. Okay. So there's the extension function. So we'll not be going this. Now let's see the state driven device. Now if we run this application now, let's run this application now. Now the count variable changes and it's expected. It's working as we have expected. Okay. So counter variable is increasing. Okay, and it's preserved during recomposition. So state driven UI. Let's learn about how the state changes. Now compose is a declarative UI framework. Instead of removing UI component or changing the visibility, when the state changes, we describe how the UI is under specific condition of state. As a result of the decomposition being called, an updated UI composable might end up entering or leaving the composition. So enter the composition, recomposes zero or more time composable, and leave the composable composition. So this approach avoids the complexity. of manual updating views as you would with the view system. It also less error prone. So this approach avoids the complexity of manually updating views as you would with the view system. It's also less error prone as you can't forget to update the view based on a new state because it's happened automatically. If a composable function is called during the initial composition or if a composable function is called during the initial if a composable function is called during the initial composition or decomposition, we say it it is present in the composition. A composable function that is not a composable function that is not called, for example, because the function is called inside an if state if function is called inside an if statement and the condition is not met is absent from the composition. You can learn about more about life cycle of composable in the documentation. So enter the composition, recomposes zero more time, composable, leave the composition. So state driven UI. you can learn about life cycle of composable. So this occurs complexity manually updating the view. So we don't need to manually updating the view system is also less error prone as you can't forget to update view based on your state because it happens automatically. So the composable is more error prone because of its declarative framework. If a composable function is called during the initial composition and the expression is present in the composition, the composable function that is not. if a UI if the UI is what the user sees, the UI state what it should see. If the UI is what the user sees, the UI state is what the app says they should see. Like two sides of the same coin. The UI is the visual representation of the UI state. Any changes to the UI state are immediately reflected. Any changes to the UI state are immediately reflected to the UI. So the output of composition is tree-like structure that is described in the that describes the UI. You can inspect the app layout generated by composing layout inspector tool, which is what you will do next. You can inspect the composing. You can inspect the app layout generated by composing Android Studio's layout inspector, which is what you will do next. To demonstrate, modify your code showing image-based open water so that if the content than 0. This text is present if the button has been clicked at least once, absent otherwise. Okay, let's add another if statement. So you have had one class. So the initial this will not show, but once we have one, then this will show. Initially, this will not be visible because count is 0. If this count is greater than 0, then this text will shows. Great one. Run the app and see the Android layout inspector by tools in layout inspector. Run the app and open the app, the Android Studio layout inspector to by navigating to see compose nodes in the inspector. Use a device with API level greater than 29. You will see a split screen. The compose region left, the preview of the app right. Layout inspector tool. Android Studio layout inspector tool. Navigate to the tree by tapping on the root element basic state Codelabs theme on the left of the screen. Expand the whole component tree by clicking expand all button. Clicking on an element in the screen on the right navigates to the corresponding element to the tree. So if you press the add so if you press the add one button on the app, count increases to 1 and the state changes. A recomposition is called screen gets recomposed to a new element. So what happens if we click on the when you click on the add one button? So if you press the button on the app, count increases to 0 and the state changes, which is state means here mutable state. Okay, mutable state changes. A recomposition is called. Then immediately recomposition is called. State gets recomposed with a new element, and the remembers the remembers the preserve the previous state. So that's what is happening. So when you examine your component tree with an Android Studio Layout Inspector tool, and now you see the text composable as well. So state drives which elements are present in the UI at a given moment. State drives which elements are present in the UI at a given moment. So defined part of the UI can depend on the same state. Modify the button so it enables until count has 10 and is then disable. You reach your goal of the day. Use the button enable parameter to do this. Enabled count greater than pass the modify the pattern so that it enabled UI count is count less than equal to 10. Run the app and changes the state count determines whether the notification that button has been disabled enabled. So button is enabled till the count is less than equal to 10. Less than 10. So button will be disabled. So we can't add more. So, okay. Remember in composition. Let me take some break of a 5-minute break, then I will come. Okay. Talk about remember and all. Let's take a break. So I think I should stop this video here and then we'll go from this, okay, in another video, okay, because I need some times to have some breakfast. We have a lot to learn in this application, okay, and remember, so